those I am calling, please respond. Others already got present. Ali Ahmed Khan, are you there? Fahim Shakil, Tanvir Hassan Imon.
Yes, sir.
Okay. Shakib Hussain. Shakib Hussain.
Yes, sir.
Okay. Mashuk Alam. Mashuk Alam. Ishtiaq Ahmed. Mahfuzur Rahman. Ishtiaq present. Ishtiaq. Okay. Mahfuzur Rahman Sifat. Sifat. Mahfuzur Rahman Sifat. Khalid Ridwan Mobin.
Yes, sir.
Tahmina Tanjin.
Present, sir.
Shifa Chaudhuri.
Yes, sir.
Misbahul Alam. Misbahul Alam. And Kamrul Islam Tushar. Kamrul Islam Tushar. Bidhan Chandra, did you complete registration? Bidhan, did you complete registration? Bidhan Chandra. Okay, all other are present.
Sir, Ami Farah.
Yes, all others are present. Okay, don't worry. All others are present. I have already taken your attendance.
Hello, sir. I have a question.
Yes.
Sir, আমি স্যার লাস্ট দুটো ক্লাস প্রেজেন্ট ছিলাম কিন্তু somehow আমি অ্যাটেন্ডেন্স দিতে পারিনি।
Why? You
স্যার
are present in the class.
নেটওয়ার্কের প্রবলেমের জন্য স্যার আমি স্যার মানে চলে গিয়েছিলাম। দ্যাটস স্যার আমি প্রেজেন্টটা দিতে পারিনি।
At least give your ID and name in the message box.
Okay, sir. Thank you so much.
If you miss that, or in case of any extreme case, it will not be counted after one class. Okay.
Okay,
If you inform me through email within before the next class, then I might consider based on your situation. Okay, no problem.
Okay,
thank you. Thank you.
Thank you so much. Thank you.
Okay, so in the last class,
স্যার
yes.
কুইজ নিয়ে একটা কোশ্চেন ছিল স্যার, আমার একটা আনসার স্যার মানে আমি করলাম অনেকবার কিন্তু এটা আনসার ওখানে স্যার মানে অ্যাকুরেট নেই, এটা স্যার ভুল আসছে আমার মেবি।
Which question? That packet switching question?
জি স্যার।
Okay, let me check first. I think it is the question is correct, no problem. So one problem is if your answer is half correct, then it is not acceptable. You have to have correct answer for both A and B. That was the problem. So that's why maybe some of you have correct answer for circuit switching but wrong answer for packet switching. In that case, your actually score will be 0. Nothing to do.
Okay sir.
Okay, but the question is out of 24. It is not out of 20, so it has some extra marks. Still you can get 20 or more. Okay, now in the last class we have already covered, let me review, 3 performance measurements parameters in packet switching, right? What were the parameters? First one was delay, then packet loss, and then throughput. For delay, normally we calculate end-to-end delay, right? But we need to understand from where those delays come. Okay, so for a single node, we have identified 4 sources of packet delay. One is packet delay. Sorry. One is node process. First one nodal processing, then queuing delay, then transmission delay, and then propagation delay. This has been already covered in the last class. And to make you understand to remove our confusion between transmission and propagation, we have used a real life example called caravan analogy, that is figure 1.17 in the textbook. And we saw that the transmission delay depends on the length of the packet and the capacity of the link, but not the distance of the media or the speed of the signal. The propagation delay, vice versa, it depends on the distance or length of the link and then speed of the signal, but not on the length of the packet or the capacity of the link. So transmission delay is L by R and propagation delay is D by S. And what is the total nodal delay? If we sum up all the individual delays, then we can get the total nodal delay. And if in a question it is not specified your queuing delay or processing delay, in that case you can assume those delays as 0, like in our example. Okay, then we have covered packet loss. We just identified 2 types of packet loss. One is for error in the bit, and second one is when the buffer in a device becomes full. For example, when a packet is transferred from one end device to another end device, there can be many number of routers in the middle. So if any of the routers has already filled a buffer, then the packet will have no space to store. In that case, that will be another way of packet loss. In both cases, the more packets lost, the worse will be performance of the network. And the final one parameter is very important parameter, throughput. Throughput is defined by the actual data rate. Normally we call it bandwidth, but bandwidth is a theoretical parameter. Like as I said, in your internet line from the service provider, maybe they say, okay, it's 5 Mbps, but you will not get 5 Mbps all the time. What you get in a particular amount of time, that is instantaneous throughput, like Sunday at 10 AM or Monday at 5 PM, that is instantaneous throughput, the actual rate at that particular time. But more representative one is average throughput. When we take the average of weekly or monthly average of our actual data rate, then that is more representative. Okay. Now, if we consider a link, let us go back to our workbook. So you can see there are 2 diagrams, figure 1.19, figure 1.20. What this describes, again, let us understand the concept for a simple scenario. For example, if there are 2 links between client and server, like in 1.19a, figure A, server to router, the capacity is RS, and client to router, the capacity is RC. So when client sends data to server or server sends data to client, and if we assume no other nodes are transferring data, because when multiple nodes transfer data, that is not easily understandable. But when only there is a single flow of data between client and server or server and client. Okay, now if the 2 capacities are specified here, and if, for example, client sends data to server, what will be the rate of data transmission? Can anyone tell me? RC or RS? Or RC plus RS by 2? What will be the rate? Just according to your normal logic.
Sir, RC.
Why RC?
Sir, actually to sir মানে আমি নিজে মানে ক্লায়েন্ট যেটা স্যার রিসিভ করবে স্যার ওইটাই তো স্যার মানে রেট হওয়ার কথা স্যার।
No, actually the rate is determined by the link capacities. So there are two links, one has capacity RC, one has capacity RS. Okay, make it simple, the minimum one, right? The minimum one. So if you move water from one tank to another tank, for example, think about that. You have multiple pipes in the middle. So when you open the tap, which rate water will flow from tank 1 to tank 2? The pipe with minimum diameter, right?
Yes, sir.
That is the logic. It cannot go more than that rate. So the least diameter pipe will determine the rate at which water will flow. Similarly, when there are multiple links and there is a single flow of data, when there are multiple flow of data, like internet, it is not possible to calculate in this way. Okay, in that case, what we do, we just in the end system, we calculate the throughput that is shown by the speed test softwares, or you can use a tool to see what is your current rate. When you download a file, you can see it is fluctuating, right?
Yes, sir.
Why it is fluctuating? Because there are many parameters that actually makes it fluctuating. When many users transmit, rate will be low. When a number of users are less, rate will be high. Okay, when there are more errors, rate will be low. So there are many factors. But if we consider only a single flow of data from one node to another node, then it is very easy to calculate. The minimum capacity will determine the overall throughput. Is it clear?
Yes, sir.
Okay,
Sir.
let us do exercise 10, then it will be more clear. Okay, in case of internet, see, in case of internet, the middle link, actually it is called the bottleneck link because it determines the capacity, because many users share the same link. See, there are 10 clients in a LAN and there are 10 servers in another LAN, but the link in the middle shared by all the servers and clients. So definitely this will be divided by number of clients or number of servers, right? So in that case, that is called the bottleneck link. Why? Because that link capacity actually determines the overall rate that we get. For example, think about exercise 10. Suppose host A wants to send a large file to host B. The path from host A to host B has 3 links. R1 500 kbps, K means kilobits per second. R2 2 mbps means 2 megabits per second, and R3 is 1 mbps, that is 1 megabits per second. Okay, tell me, assuming no other traffic, if there are other traffics, then it will be complicated. It is not simple to calculate. But if there is no other traffic in the network, what is the throughput?
500 kbps.
Very good, Shahadat. 500 kbps. That is the minimum rate. You cannot send more than the minimum rate. It doesn't matter whether this link is in the middle, this link in one side, or this link is in the last link. The minimum rate link will determine the throughput. So the answer will be 500 kbps. Okay, so if we do exercise 10, then our throughput will be minimum of 500 kbps, then 2 megabits per second, and then 2 megabits per second, and then 1 megabits per second. So it will be what? It will be 500 kbps. Is it clear? Very simple. So when a single flow of data, definitely the minimum rate link will be the throughput. Now, based on this throughput, suppose a file is transferred, okay, from A to B, and the file is 4 million bytes, not bits, bytes. Dividing the file size by the throughput, roughly how long? So you have to calculate the delay. Again, it is very simple. When you calculate the delay, it will be file size divided by what? Throughput, right?
Throughput. Yes, sir.
So it will be 4 million bytes. That means 4 million bytes means 4 into 10 to the power 6 into 8, right? You have to convert to bits.
Bits.
You have to make the unit same. Divided by 500 into 10 to the power what? 3. Okay, so it will be the result x seconds. I don't know what is the value, so calculate this, no problem. So this is the delay. Now it says repeat A and B now with R2 reduced to 100 kbps. What will be the change?
Yes, sir. Throughput will be changed.
Throughput changed.
Right, throughput will be 100 kbps. Very simple. Okay, is it clear?
Yes, sir.
Okay, so these are actually the performance parameters in packet switching network. Okay, now do one more exercise. That is exercise 9. Consider following. This is based on the delay, different types of delay, where the sender transmits one packet of size L equals to 1 kilobyte. Okay, and the link speeds are same. R1, R2, R3 all are same. What is the value? 1 megabits per second. The length of each link is 100 kilometer. Now compute the end-to-end delay for the following situations. We assume the propagation speed of the packet is 20,000 kilometer per second, and the processing time of the packet at each router is 5 microseconds. See, now all the information there. L is given, R is given, right? So L by R, transmission delay. Then D is given. What is the value of D?
Distance
Right, 100 kilometer, right?
100 kilometer.
100 kilometer. And then what is the value of S? 20,000 kilometer per second. What is the value of processing delay? 5 microsecond. But see, this 5 microsecond is for each router. So it is not counting the processing of sender and receiver. Okay, it is assuming I have to calculate the delay at the point of packet coming to receiver's interface, not processed by the receiver. So that's why 2 routers in the middle. So processing delay will be 5 microsecond into 2. If there were 5 routers in the middle, then 5 microsecond into 5. Did you get my point?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, now do it. Calculate it with your calculator, paper, pencil, and post the result in the message box. You have 3 minutes to do that. So exercise 9, it will be here. Exercise 9. Transmission delay will be number of links into L by R. So there are 3 links. Actually, it will be like this: L1 by R1, right? Plus L2 by R2 plus L3 by R3. But because all the link has same capacity and the packet size is same, so we can write this like 3 into L by R. So what is the value of L by R? It is 1 into 10 to the power 3 into 8, right?
Yes, sir.
Bits. Okay. And then divided by 1 into 10 to the power what? 6. Similarly, you can calculate the propagation delay. Again, there are 3 links. Each link has same distance. That's why we can directly calculate like this: 100 divided by 20,000. See, all the links has the same speed, same distance, and also distance and speed both given in kilometer, right? So we don't need to convert it into meter. Is it okay?
Yes, sir.
So now you can calculate, and then processing delay will be, since it is only for routers, so it will be micros. It is not second. If you can, okay, if you can multiply by 10 to the power minus 6, then you can also make it second, but it doesn't matter. You can add it with microsecond unit, no problem. What is the value of queuing delay? What is the value of queuing delay? 0, right? Nothing is said in the question. Okay. Now you have to find out total delay and do it yourself. Okay. Do it yourself. Okay, is it clear? Anybody got final answer? Okay, no problem. Do it. It is your homework. You don't need to submit, but just complete it before the next class. So this is, I think, end of section 1.4. Any question on section 1.4? Okay. We will start section 1.5. That is the last section and very, very important section. I think you have already covered it in data communication for computer science students, also in communication theory for EEE students. But you will, this is very important. So we'll again learn it or review it in full details. And there are lots of example questions in the workbook, so that if you perform the exercises or examples efficiently, I think you should have a good understanding about the protocol layers or layering concepts. The first thing is, anything you do, any protocol you study, any software you develop, okay, in networking, any kind of security you implement, everything depends on these protocol layers, either OSI or TCP/IP. So it is a very important part of anything in networking. So please give a good effort understanding these layering concepts. There is another knowledge test 2. There are some sample questions. Try it yourself, and if you have any questions, we can discuss later or during the review before the midterm. We can discuss this type of questions. Okay, so section 1.5, this is protocol layers and their service models. Before I go through this, let me show you one animation. Let me show you one animation on layering concepts. Okay, so this animation actually describes the entire process first, and every step has a good description, and it is based on OSI, Open System Interconnect model, and we know every practical model is based on OSI. For example, the mostly used practical model is TCP/IP, but TCP/IP actually rearrange the layers based on OSI. So if you understand this animation, every step, read every step, then I think it will be a good source of understanding for you, the layering concept. Okay, in this case, we are taking very simple scenario where you can see a laptop is connected to a server, and in the middle there are 2 routers. Okay, and in OSI model there are 7 layers: application, presentation, session, transport, network, data link, and physical. We will again review functions of each layer one by one, but first see what happens when we send an email. We take sending email as an example, but you can also use web browsing as an example where a web page is requested by the client. But in this case, we are assuming that I am writing an email from the laptop as a user. Laptop is the client, and that email will be sent to the email server through these 2 routers. What happens? See, okay, very important illustration here. See the bidirectional arrows. These bidirectional arrows means every layer in the source will only correspond with the same layer in the destination. So application layer in the source will correspond to the application layer in the destination. For example, when we do web browsing, we use a browser, right? So browser is the application in my machine, and then browser communicates with the server at the like facebook.com, google.com. There is a corresponding server software. So my browser software is communicating with that server software, but they are not communicating directly. They are communicating with the help of lower layers, but logically, an application will only communicate with the application of the destination. So this is the bidirectional arrows, and you can see the lower 3 layers, network, data link, and physical. They have also bidirectional arrows, but network layer is also present in a router. So since router works up to network layer, so the bidirectional arrow works between nodes, between client and router, router and router, and router and server. Another very important observation here. See, in both routers, data link layer and physical layers boxes are broken. Why this is broken? That is another issue. Okay, let me make it clear. When we work in layers, keep in mind always there are 2 parts. One is software, one is hardware. One is implementing in software, another part is implementing hardware. Now, out of these 7 layers, very interesting, out of these 7 layers, all the layers up to the upper half of data link implemented in software, and only the lower part of data link and physical are hardware. So when you consider a machine, that machine has cables connected, or in case of wireless, in both cases, wired or wireless, there is a LAN card. We call it LAN card, or network interface card, or an interface connected in the built in the machine, through which the signals flow. So keep in mind, only hardware can convert bits to signals, right? Software cannot convert bits to signals, because signal is different for optical fiber, for wireless, right? For different media, signals are different. So that's why I see the data link and physical has two boxes, because router has how many interfaces? How many ports? Two ports. See, one on the left, one on the right. So maybe on the left port is Ethernet, wired LAN. On the right, maybe wireless. It can happen. So these are two different physical ports, and that's why the signaling will be different, and that's why the layers connected to hardware must be operated in two times. One is when receiving the signals, another one is when sending the signal. So that's why these two boxes are broken. Okay, now let us progress. This is Ethernet LAN. This is probably WAN, wide area network. ATM is a technology. It can be internet, through internet, and then there it is connecting to a server that is also part of another LAN. Now I'm writing a hello world message, sending to a friend through email. So email is the application layer. Now what is the application layer responsibility? It provides the interface to the application programs, actually basically for the users. So if you have no browser in your machine, but you have 100% connectivity, right? Network connectivity, it is of no use. You cannot browse. So browser is the application for you to access or to use the network. So we will compose an email using an application, then send that email to the next layer. Okay, what is the purpose of presentation layer? The purpose of presentation layer is converting the application data to network usable format. What are the two examples? One is compressing the data. Why we compress? To make more efficient use of the link bandwidth. Another one is encryption. Why? For security. So compression, encryption, that is kind of changing the presentation of the data to a different format. Like, you know, .jpg is a format for image compression, right?
Yes.
So presentation layer actually, if needed, if not needed, presentation layer will do nothing. But if needed, it can compress, it can encrypt. After its own work, and you can already see every layer puts a header. So email was the original data, but when we send email, we send to, right? To, from. When we send a letter, we write the address of the receiver on top of the envelope. These are not real data, real message. These are the data to send the real message to the particular destination correctly. So these are called headers or overhead. So every layer will add its own header, and what it will do, it will put some information in the source so that the destination layer can use those information. For example, if presentation layer compresses the data, what was the algorithm? The receiver must know the algorithm, right? Otherwise,
Yes.
receiver cannot decompress. If encrypted, receiver must decrypt. So every layer will add some headers so that the corresponding layer in the destination will be able to interpret what to do. Okay, so presentation layer performs its works. Then it sends session layer. Okay, session layer. What is the purpose of session layer? You mean session, dialogues. We use we create multiple connections simultaneously in my machine. I create separate tabs in my browser. At the same time, I am using some Skype conversation. I am using WhatsApp. I am using many other network connections. So session layer's responsibility is to actually keep trace which connection is represented by which data, or separating each connection, like communicating over two telephones simultaneously. It sometimes happens in an office MD. There are 3 telephones in the MD's room. So one actually rang and then he started communicating. By the time second one started ringing, again communicating. But in these 2 communications, maybe one at the from home, maybe one from another office. So he or she has to keep trace about the subject. Otherwise, what will happen? Communication will be hampered. So session layer's responsibility is to trace different sessions separately. Okay, then up to this layer, up to session layer, actually this is part of the application. That's why TCP/IP merge this presentation and session into application layer, because we cannot separate this in a single application. So when we come to the session layer, maybe there are 9 or 10 connections. Every connection has separate data. So the lower 4 layers, transport, network, data link, and physical, has the responsibility to transfer that data to the destination. So they will not know what is in the message. So after the session layer, the scope will be now one single link. So transport layer will work if there are 10 different connections. For each connection, transport layer will work separately. So we are sending an email. Now that particular session data will be received by the transport layer, but that data may be not manageable in a single packet. Maybe it is size is very large. For example, 10 megabyte, or maybe 100 megabyte, or maybe 1 gigabyte. So it is not feasible to send the entire file, entire content at the same time. So the first responsibility of transport layer is to take data from session layer or application and then convert into manageable segments. Manageable, divide into smaller segments. But there are some other responsibilities of transport layer, like reliability. So if it converts the packet data into segments, suppose there are 100 segments, and during the transmission maybe 5 segments are lost, then the transport layer must retransmit all those segments from source to destination again. So that is reliability. And there are some other responsibilities of transport layer we'll see later. But then transport layer will send each segment at a time, each divided segment at a time through network layer. So if there are 100 segments, it will send one by one, not 100 segments at a time. So when we come to network layer, we can assume now network layer receives one particular segment, and then network layer adds its own header. Then the segment becomes, that particular segment becomes a packet. And the responsibility of network layer is mainly to find out a route or path, an efficient path, best path through which that packet can be transferred to the destination. And then network layer will forward the packet according to the path. But still, keep in mind, we are in the software or hardware. Did we complete the software part yet?
No, sir.
No, we are still in the software. So when you think about the software, that means you cannot convert the bytes or bits into signals. So that's why network layer must hand over the packet to data link layer, and so that data link layer can convert that packet. Packet means actually a number of bytes, a number of bits. So data link layer will take the packet, data link layer will add its own header and trailer, and then data link layer will send the packet bit by bit, converted as signals, and then put the signal in the physical media. So the physical media is, physical layer is nothing but the physical media. It can be optical fiber, it can be UTP, it can be air, wireless signal. So in that case, the responsibility of physical layer is just to carry raw signals. Okay, one more thing, let me make it clear. In a device like laptop or a server, we know there are two types of address. IP address, I think we all are aware of IP address. IP address is the logical identification of a device that is connected to the network. Why logical? Because this is implemented in software. So that's why IP address is assigned in the network layer, because network layer is implemented in the software. So anytime we can change IP address, just set the IP address, it will take a new ID. But there is another ID that is we call physical address or MAC address that is actually bound to the hardware. So when you buy a LAN card, network interface card from the market, a MAC address is already written there. Okay, now why we need two addresses, it will be clear later on, but for now just make sure network layer assigns IP address. So network layer has two responsibilities, that is assigning IP address, and second one is finding the best path from a source to a destination. And data link layer assigns MAC address, and data link layer scope is only one single link. That means transferring the data from one node to the very next node. The data link layer is not aware of the final destination of the packet, okay? But network layer is aware of the final destination of the packet. Okay, see, the IP address is given here. Those who are doing lab, I think network lab, we will go through this IP addressing very details, but for this theory course we need the basic of IP addressing. And see, every device, every port device has a corresponding MAC address. Another thing is a port number. Just a little bit introduction about port number. Port number is used by transport layer. Why? Because as I said, application, presentation and session, up to session, there can be multiple simultaneous connections. Every connection will have different data. So in that case, transport layer takes data from one single connection. But if there are 10 connections, then transport layer will receive data from 10 separate connections in the source. And then when transport layer transports the data to the destination, again there can be multiple different applications. So transport layer needs to identify different applications in the same machine, same host. So transport layer uses another ID that is called port number. So 3 ID. Just remember, it will be more clear when we do some examples later. So transport layer uses port number, network layer uses what? IP address, and data link layer uses MAC address. Okay.
Address.
Okay. Now
Sir.
let us. Okay. Any question?
স্যার পোর্ট নাম্বারটা কি স্যার সেশন লেয়ার ক্রিয়েট করে না স্যার?
Actually, yes. When you implement a program in doing programming, in that case you have to create a session. When you create a session, you have to know not only port number, you have to know the IP address of the destination also. But for the time being, for now, just make sure you understand transport layer uses port number to identify application. Network layer uses IP address to identify another host, and data link layer uses MAC address to identify the very next node connected in the link.
ওকে স্যার।
Okay. We'll do one exercise in chapter 1. I think then it will be more and more clear. Those who have yet has some confusion, I know it will be clear. Just let us finish this example and then we'll go to that particular exercise. Okay, now, okay, in this stage, where is the data? Is it in laptop or in router or in server? Until this point, see, the email the application data ultimately pass through presentation session transport network data link. So where is the data? Is it already left the laptop, or it is still inside laptop?
I think it's still inside the laptop.
Very good. It is still inside you have to visualize. Networking, see, you have to visualize. So it is still in the laptop. How can you understand? Because whenever it leaves the laptop, it must go through the physical layer, right?
Yes, sir.
Without physical layer, if you have no connection, nothing will happen. So still data link layer is not place the packet into the link. So that's why it is still inside the client. It will laptop. It will leave the laptop through the interface, right? LAN card interface hardware when data link layer places this in the link. See, so now it is placed in the link, then it goes through the link Ethernet LAN, and then router receives the data. See, when router receives the data, again router's physical layer first receives signals, then handed over signal to data link. Data link converts signal into bits, then converts bits into bytes, and then convert again to a frame. That is called a frame, the unit in data link layer. And then data link layer needs to hand over the frame to the network. Before handing over to network layer, it will remove header and trailer. That means it must process its header and trailer. So see, now it will be clear why there are two boxes. Okay, because this interface, left interface, has a MAC address, right? So whenever the source in the laptop sends the frame, it adds source MAC, that is laptop's MAC, as the source, and then router's MAC as the destination. Now router receives the frame, and then before handing over to network, it must process the header. Process means it makes sure, okay, this packet is for me. Then it will hand over to the network by removing the header and trailer. That means when you remove header and trailer, that will be packet. It is sent to network layer. Network layer will decide which path to forward the packet. But again, network layer is implemented in software or hardware?
Software.
Software. So again, network layer must hand over to the other link, the other side of data link layer, to forward to the next node. So see, again, data link layer adds a new header and trailer. That means now the MAC address of the right side of the router will be the source, and the MAC address of the left side of the router 2 will be the destination. Is it understandable? So that
Yes,
means a new header is added and then again forwarded through the physical layer. But somehow some error happened. We don't know what is the reason, but the packet is discarded. If there is an error, no device will process the packet. It will discard. Now, when the packet is discarded, who will retransmit? Transport layer. Okay, that is reliability. So network layer is not reliable. Transport layer is reliable. That means transport layer will retransmit the lost packet. How source transport layer will know? Actually, destination transport layer will send a feedback that is not shown here. But definitely destination sends a feedback to the source that I did not receive that packet. Then source will retransmit. Okay, source will now retransmit. And then it will go to from first router to second router, same way. Okay, same way, same way. Again, for some reason, the packet is lost. But in this case, you can see the bidirectional arrow between data link. That means what? That means data link layer can also provide reliability. Okay, so keep in mind, reliability means whenever a data packet is lost, who will retransmit? So we know transport layer provides reliability, so transport layer can retransmit. But in some cases, data link layer can also provide reliability. But it is not mandatory. It is not fixed. See, out of these 3 links, only the last one provides reliability. So it depends on which protocol you implement, which protocol you use. But keep in mind, data link layer also provides reliability. In that case, even if packet is lost, the previous node will retransmit from the data link layer. It is not needed to go back to the transport layer. So is it better or not better?
Better, sir.
Definitely better. Time will be less. But the problem is you cannot make sure every data link layer will provide reliability. So that's why transport layer will be there. If data link layer does not provide reliability, transport layer will provide reliability. So you have a backup. Now, okay, that packet is reached by the server. Now, server will process the same way. First, data link will process, no error, hand over to network, process, no error. Process means now network layer will see, okay, this is my IP address, yes. So this is for me. So now hand it over to the transport by removing its own header. So if packet header is removed, this will be a segment, transport layer will receive a segment. So if there are 100 segments, then all these activities will be repeated 100 times. That is not shown here. But then transport layer will reassemble the packets, got the original message, and then hand over to session, hand over to presentation. If compressed, then decompressing here. If encrypted, decrypted here. And then finally handed over to application. So see, the source sends an email and the receiving application receives the email. Any question? If you have any confusion, just go back. I will upload this animation, and also you have to install Flash Player. Just download a Flash Player from the internet, and then you can run this in any browser, or you can run this in any player. Like I am using GOM player. There is a player, GOM player. Okay, so you can go through, and every step is fully described here. Any question?
No, sir.
Okay, I think we are out of time today. So that is end of the demonstration, and it is also showing you the TCP/IP model, relationship between OSI and TCP/IP. Okay, and then description here. Okay, so the entire layering concept is actually revised in this case. Okay, now you have to read from the textbook first. Why we should use layering? You have to find out some reasons that is given in the textbook. One possible reason is when we do a complex task, we actually simplify to individual tasks, right? When you do a large programming, you use functions, you use modules, solve smaller problems, then you just reassemble all those. So that is one possible reason, but there are some other reasons. Find that from the textbook, why layering is used. And then the animation covers everything, but I have put some more and more descriptions, diagrams here. The same thing repeated again and again to have a clear understanding, better understanding. Just go through this, and then in the first half of the next class, we'll do some exercise before we go to chapter 2. Okay?
Okay, sir.
Okay, then if there is no question, I think we can finish today. And see you in the next class. Allah Hafiz.
Okay, sir. Assalamu alaikum, sir.
Walaikum assalam.
আসসালামু আলাইকুম স্যার।
Walaikum assalam.
আর আমি অ্যাটেন্ডেন্স দিতে পারিনি স্যার আজকে যখন
Okay,
ক্লাস শুরু করছেন তখন
put your ID and name in the message box before leaving. Okay.